Today we will see how to prepare a mesh for any arbitrary shape or any arbitrary volume in the case of 3-dimensional objects. The basic problem is that if we have any arbitrary shape like this and we want to make a finite element mesh in it, we cannot make any arbitrary mesh. Because let us say if we want to make a mesh which is just like this, consisting of rectangular elements, okay, firstly we might not get the best result in this case, and secondly the numbering pattern might also not be perfect, and our boundaries might also not come out to be very nice. Okay, and the biggest problem would be that when we want to make a mesh like this, making it manually is not going to be possible, because we will have to give the geometric coordinates for each and every node. Okay, so making a mesh for any arbitrary shape, we have to have some automatic methods for doing that. Okay, for instance, for this I might like to make a mesh which would look something like this. Okay, that means each of these is a quadrilateral element, a 4-noded or 8-noded quadrilateral element, and we get a mesh like this with numbering going 1, 2, 3, 4, 5, 6, 7, 8 and so on. Okay, this might be one possible way in which I might like to mesh it, but I need some automatic method for generating this mesh. Okay, if we just have a simple rectangular object, okay, that means it's an object like this, then generating a mesh is a straightforward thing. All that I have to do is take a rectangular array of blocks. Okay, if I take a rectangular array, I will get an array something like this. Okay, and for this array I can generate my node numbers and so on. Okay, let us say this is element number 1, 2, 3, 4 and so on, and my node numbers can be 1, 2, 3, 4, 5, 6 and so on. Okay, 7, this one will be 8, etc. Okay, but if I have an arbitrary shape, then getting the coordinates of each and every node, we need some algorithmic method for doing that. Okay, so what we do is, if we have any shape, let us say the shape that I had drawn here, we will try to map this shape onto a rectangular block. Okay, that means if I have a rectangular block like this, I will try to map this shape onto this block. Okay, and then in some sense I like to twist the elements so that the two shapes become identical. Okay, I will just explain what I mean by that. For example, if I take this block, divide it into 4, okay, and then I say this is block number 1, block 2, block 3 and block 4. And now I say that this block 4 does not exist. Okay, that means this block is a void block. And then I say in addition to that, this edge and this edge, these two edges are merged together. Okay, so I will combine these two edges so that this node will become identical to this, any point here will become identical to a point here and so on. Okay, then this shape would become something like this. Okay, so this this edge and this edge have been combined together, so what I will get will be some shape like this. This will be block number 1, this is block number 2 and this is block number 3, and the block number 4 which did not exist has vanished. Okay, now this is a rectangular array of blocks. I can do my node numbering in this, and that can be mapped onto this shape. Okay, so similarly for this, we will take a rectangular array of blocks and map that rectangular array onto this shape. Okay, the basic idea is that let's say in each of these blocks I decide that we will have a mesh. Let's say in this portion I have a mesh of this size. Here maybe I have a mesh which is finer. Here also maybe I have a finer mesh, and here I have a mesh of this size. When I join them, what I will get will be in this region my mesh is going to be coarse. Okay, so here I will get a mesh which will look something like this. Here I will get a finer mesh, and similarly here also I will get a finer mesh. So depending on the portions where I want to have a fine mesh, I can choose a different mesh density in different blocks, and then merge the edges which are to be joined together. Okay, so for this complete process we have a simple algorithm which will which after this mapping has been done, that means after an array of blocks has been mapped onto a given shape, we can generate the element numbers and the node numbers. Okay, but we have to be careful about one thing, that the node numbering should be optimal, or should give us good results. Okay, because we have already seen that if our node numbering is not good, okay, that means this, let's say 1, 2, 3, 4, 5, 6. If we don't have a appropriate node numbering, then our stiffness matrix is not going to be a banded matrix. Okay, so we will not get a good stiffness matrix. Okay, so therefore we have to be careful about the node numbering in these algorithms. Okay, that is a critical thing as far as any of these mesh preparation algorithms are concerned. Okay, and in this algorithm, the first step is that we have to map any shape or map any arbitrary shape to a rectangular array of blocks. Okay, so we have to map any arbitrary shape into a rectangular array of blocks. That is the first step that we have to do in any algorithm. Okay, then after this is, let's say, the first step. After this we have to identify void blocks. Okay, like in this case we said that this block 4 is going to be a void block. Okay, and once you have identified the void block, the next step is to identify edges to be merged. Okay, that means in this case we said this edge is to be merged with this edge. Okay, so this way we might like to merge different edges in this array of blocks. Okay, after we have done this, then we have an array which will look something like this. Okay, and we can have different types of mappings. For instance, if we consider this array of blocks, this is block 1, 2, 3, 4, 5 and 6. Okay, and a final object is, let's say, a circular plate with a hole in it. Okay, then what we can say is that we will take this edge and this edge and we will merge them together. Okay, if I just give them numbers 1, 2, okay, I will take this edge and this edge and I will merge them together. Okay, and I will consider these two blocks to be void. Okay, so I consider block 2 and block 5 to be void, and I consider 9, 10 to be merged with 12, 11. Okay, 9, 10 is to be merged with 12, 11, not with 11, 12. Okay, that means 10 and 11 will be merged together and 9 and 12 will be merged together. Okay, similarly 2 and 3 will be merged together and 1 and 4 will be merged together. Okay, then this shape would be divided into 4 blocks which will look something like this. Okay, so this would become 6, this would be 5, this will be 9, this is 10, and the same time this will be 12 and 11, this is 7, 8, and this is going to be 2 and 3, and this is going to be 1 and 4. Okay, this is one merged edge and this is also a merged edge. Okay, so this in this manner with a hole can be mapped onto this array of blocks. Okay, and then we will get a mesh for this array, keeping in mind that these edges are merged and these blocks are void. Okay, so this way if we have any arbitrary shape, our task of preparing the mesh will finally come down to the main task that we have to mash this arbitrary shape into an rectangular array of blocks like this. Okay, so after this stage, okay, after we have identified the edges to be merged, the next step is to decide number of elements in each block, okay, or to decide the mesh density. Okay, so let's take the simple example that we had earlier. Okay, this is, let us say for this particular case. Okay, that means this quarter of a circle or quarter of a circular plate is being mapped onto this area of 4 blocks. Okay, so we get these 4 blocks. Let us say this is number 1, 2, 3 and this is 4. Okay, then maybe we decide that we will have a mesh density of 2 by 2 here and higher density here. Okay, and out of this, of course, block 4 is a void block and this edge is being merged with this edge. Okay, this is a void block. Okay, so we will carry out the complete mesh generation algorithm on this array of blocks. Okay, so the step was to decide the number of elements in each block. The next step is number all nodes, let us say from 1 to n. Okay, so in this case the numbering can be done. We should look, let us say this is 1, 2, 3, 4, 5, 6, 7, we have to number all the nodes including the nodes inside the void block right now. Okay, so this one will become 24. Okay, in this case we number them from 1 to 30. Okay, then for each node we define a label. Okay, so each of these nodes will give a label to it and will say that initialize the label of all nodes as -1. Okay, so for each of these nodes we will give it a label and that label is, let us say, -1 for each of them. Okay, so let us say this is all these nodes will initially be given a label of -1. Okay, and then we will go and change these labels. Okay, so that is the initialization step we are carrying out. Okay, then for nodes in void blocks, we will put the label equal to 0. Okay, for nodes which are inside a void block, we will put the label equal to 0. That means that this label will be changed to 0, this will be changed to 0, this will be changed to 0, and this will be changed to 0. Okay. These labels which are on the boundary, they will not be made 0. Only those labels which are inside a void block. Okay. These labels are common to a void and a non-void block. Okay. So these 4 nodes, their label will be made 0. Okay. The basic idea of making them 0 is that in the final numbering we do not want these nodes to be included. Okay. So we will make these 4 nodes, the label of them to be 0. Then we say the next step is for points to be merged, okay, that in this example node 28 is to be merged with node 20, okay, node 23 is to be merged with 19, okay, and 18 is of course common to the 2 edges. Okay, so for points to be merged, we will say label of higher numbered node will be made equal to the point number or the node number of lower number point. Okay, then so point number or node number of lower numbered node. Okay, that means 28 is to be merged with 20. Okay, so label of 28 I will change that to 20. Okay, that is what I am saying here. The label of the higher numbered node, the higher numbered node is 28, its label we put equal to node number of the lower numbered node. The lower numbered node is 20, so its label will be changed to 20. Okay, so instead of this -1, I will change this to 20. Okay. Similarly, between 23 and 19, the label of 23 I will change that to 19. Okay, because 23 is to be merged with 19. So the label of 23 I will change that to 19. Okay, not to the label of 19, I will change it to the number 19. Okay, similarly the label of 28 will be made 20. Is this step okay? Okay. Once this is done, then we come to the main numbering loop. Okay, now you start assigning node numbers. Okay, and what we do is, if the label of the point is less than 0, okay, then we will say node number is equal to, let us say, some number nn, and we will say nn is equal to nn plus 1, initialize as nn equal to 1. Okay, we do this initialization and then we cover all the nodes and we say if the label of the point is less than 0, the node number is equal to nn. Okay, that means we will start with point number 1. If its label is negative, its node number will be made equal to nn. We have initialized nn as 1, so this will take a node number of 1. Okay, then I will say nn equal to nn plus 1. I will come to the second point, again the node number is negative, and this will become 2. Okay, this point will become 3, this will become 4, this will become 5, and so on. Okay, so node number of this node will become 1, for this node will become 2, and so on. Okay, so this will become 6, this one will become 7, this will become 8, 9, 10, similarly 11, this one will become 12, this will be 13, this will be 14, 15, 16, 17. For all these nodes right now the label which I have written in blue over here is negative. Okay, so the node numbers will remain the same for all of them, 19, 20. Okay, here also the node number is negative, this will become 21. Here also the label is negative, this will become 22, but here the label is not negative. Okay, so what do we do in that case? So this is only when the label of the point is less than 0. Okay, so if the label of the point is positive, we say if the label of the point is greater than 0, okay, then we will say node number will be equal to node number of point numbered as label. Okay, the node number of the point numbered as label. That means for point number 23, the label is positive. So the node number for 23 will be the node number of the label. Okay, that means node number for 23 will be the same as the node number for point number 19, and for point number 19 the node number is 19. Okay, so for this point the node number will be given as 19. Okay.
For storing this information also in an array, for any point its label number, its node number.
Yes, yes.
This is superfluous information.
Again?
This is superfluous.
Why?
So we could have straight away stored the node number, I mean as the point itself.
See, right now it's a very simple thing, so you can make out which two nodes are being merged. Okay, but let's say if you have a number of elements, I made the other let's say in this case you have two edges being merged here and two edges being merged here. Okay, we also might have situations where more than two edges are being merged together. That means 9, 10 is being merged with 11, 12, which is also being merged with 7, 8. Okay, in such case deciding just by looking at the figure is not going to be so easy. Okay, right now we have taken a very simplistic example, and especially when this is extended to 3 dimensions. Okay, just deciding giving the numbering directly is not going to be possible. Okay, so we have this, it's a simple labeling mechanism. Okay, I was saying we are maintaining both the arrays, and in this step, okay, this step is just equivalent to saying that the node number of the point will be equal to node number of the label of the point.
It means you are also storing that corresponding to which label, which node number is there. I mean, for a point.
I didn't get you. Corresponding to which?
I mean, for a node number, we know which label number it is.
I am storing for every node, for every point I am storing the label. Okay, that label is what I have written here in blue, -1, 0 is here and 19 and 20 here. Okay, I am storing this as a label, and finally the node numbers to be given to this point, that I am finding out. I am storing that in an array. Okay, that array is, let's say, an array n of point, just one sec, n of point will finally store the node number I am giving to every point, and I am having another array which is the label. So initially I am making an array called label, and then I am using this array to make an array called point. Is that?
What is the first array about?
The first array is the label for every point. Initially -1 for all the points. For the void blocks, whichever points are inside the void block, I am putting them to 0. Okay, and the edges which are being merged, I then change the label of those points to the point number of the lower numbered point. So I get this array as label. Once I have this array as label, I use that array to give a number to every point, and that is going to be my global node numbering in my final finite element mesh.
Sir, how do you do assigning of node number of 23? Sorry, label of node 23 is assigned 19.
The label of 23 is 19.
How do you do that? How do you identify 19?
We said that this edge is to be merged with this edge. Okay, so all the nodes on this edge are to be merged with this edge. Okay, so 18, 23, 28 is to be merged with 18, 19, 20. So 19 is to be merged with 23, 20 is to be merged with 28. Okay.
It would again be difficult for complex objects to identify which edges to be merged in.
That is the job which has to be done at one of the earlier stages in the algorithm. We decide identify edges to be merged. We first identify the blocks, identify void blocks, and identify the edges to be merged. And that has to be done at a stage when we are trying to generate this shape from a rectangular array. See, the basic thing is we are starting with a rectangular array. Okay, in this rectangular array we want to map this onto any arbitrary shape. Okay, so that is an operation which will require some conceptual mapping. That has to be done by the person who is trying to generate the mesh. That is not being done in an algorithmic manner. Okay, but once that mapping is done, then we can have a simple labeling algorithm to generate this mesh. The algorithm is very straightforward. Okay, we are just generating the labels, and on the basis of that we are getting the node numbers. Okay, any other question on this? So, if the label of the point is less than 0, we just assign it the node number. If the label of the point is greater than 0, then we assign it the node number corresponding to the node number of the label. But if the label of the point is equal to 0, we simply ignore it. Okay, because if the node number if the label of the point is equal to 0, that means it's inside a void block. So that should not be numbered. Okay, so we'll get node numbers corresponding to each of these points. Is that okay? So this is as far as getting the node number is concerned. What we also need to get is the geometric information. That means what are the geometric coordinates for each of these points. Okay, how can we get geometric information? We have started with a shape like this. Okay, so if I consider, let's say, block number 2, in this block number 2 I have, this is one edge and this is a second edge, okay, third and fourth. So this is one edge, second edge, third edge and a fourth edge. I have the geometric information for this object.
We can match the edge lengths.
Not just the edge lengths, we can take these nodes, the corner points, and then for getting the intermediate points, these points, all these points, we can do a simple quadratic interpolation between the nodes. We can get these points by doing a quadratic interpolation. So effectively the actual element that we will get will have a straight edge over here, similarly a straight edge here and a straight edge here, if we are taking elements with straight edges. Okay, if you have a 4-noded quadrilateral element, it has only straight edges. If you have an 8-noded quadrilateral, it will have a quadratic edge. Okay, so if you are taking element with straight edges, we will get straight edges on all these locations. Okay, and these points will be obtained by quadratic interpolation between these two. Okay, these 2 points will come, let's say in this case, this edge will correspond to this. Okay, I know this point and I know this point, and I can do a quadratic interpolation between them to get this edge. Okay, so each of these edges, each of these nodes, their locations can be obtained by quadratic interpolation and their numbers can be obtained by this algorithm. Okay, and element numbers will again be given to these to these, let's say, blocks in a row. This is one element. Okay, let's say E1, this is E2, E3, E4 and so on. Okay. Any question with respect to this mesh generation algorithm?
So why don't we, for example, for assigning the node number for 23,
Yeah.
why don't we say node number 23 is assigned its label?
Is assigned its
Label.
label. Okay, because the node number for 19 might not be 19. In this case, it is 19.
The label for node 19.
The label for node 19 is -1, but the node number for point 19 might not be 19. Okay, because right now we have only one edge to be merged. Okay, in the other example that we had, when this edge is being merged with this and this edge is being merged with this, let's, if you do a simple algorithm for this quickly, this will be -1, -1, -1. Initially everything is -1. Okay, 1 is to be merged with 4, so this will be changed to 1. 3 is to be merged with 2, so this will be changed to 2. Okay, and here 12 is to be merged with 9, so this will be changed to 9 and this will be changed to 10. Okay, now if we start doing the node numbering, this will take a node number of 1, this will take a node number of 2, this will take a node number, will take the label of this and the node number of that, this will become 2, this will again become 1, this will become 3, this will become 4, this will become 5, this will become 6, this will become 7, this will become 8. Now 11, that is being merged with 10. So the node number for this should not be 10, but it should be 8. Okay, so we cannot give this the node number. We cannot give this the node number just as this 10. We have to give it as the node number of this node 10. Okay, so this will be the node number given to this will be 8, and given to this will be 7. Okay, I haven't taken a finer mesh right now. You can take a finer mesh and repeat the algorithm. Okay, this is not the only algorithm for mesh generation. Okay, this is one algorithm. They have other methods available, which some of you might have tried on Patreon, that you can give mesh seeds and get a mesh automatically and so on. Okay, there are other algorithms also which are available. Okay, but this is one simple algorithm which gives some idea of how meshes can be generated. Okay, any questions on this part? Okay, there are no questions. With this I will wind up the finite element portion, and the next class we will now start with curves, surfaces and solid modeling. Okay, so that is all for today.